Welcome guys to an episode with the Doomtell. Today we are having another lecture type video coming out your way. We're going to be checking out gaming peripherals and hardware optimization topic. Now on this channel we have for the most part talked about hardware, gaming, and just general stuff like how to have fun on a low budget. That's pretty much been the topic of discussion. Today we're going to kind of widen the scope of our topic, and we're also going to help tweak some of the settings that some gamers might prefer over regular folk. So the topic is gaming peripherals and hardware optimization. Today we're going to be talking about in-house Windows architecture to better understand what's going on in the background and to understand how to optimize your gaming peripherals. The peripherals in the topic will obviously be your keyboard, mouse, monitor, sound, which is less of a peripheral nowadays, considered kind of like a just a given, and lastly we're also going to be talking about loading. So these topics are, I would argue, less and less important for gamers nowadays than it used to be. And that's for a lot of reasons, but the main reason is that peripherals have gotten so much better at dealing with this kind of stuff that it's pretty hard to kind of like get the information you might want. Now, you guys are kind of lucky because, I'm personally a, computer scientist. I have just graduated from data science. I have a pretty good understanding of the hardware architecture. And I've also kind of studied on computer libraries, especially Windows. So very early on as a young lad, I was very interested in Windows. And so although that has closed me some doors when it comes to understanding like Unix kernels and things like that, it has opened me to that whole gaming side of things with Windows. So I understand it a little better than some other people. Now, obviously, don't talk to a computer engineer about this. I'm sure some computer engineers might cringe at some of the topics I have here. Just keep in mind that I'm trying to have a kind of layman approach for regular folk, and I'm not trying to give false information, but I am trying to have very simple information for regular folk. So we're really going to have 4 topics. The very first topic is that Windows is garbage. Now, as a gamer, we don't really get the choice of running anything else. PC gamers have to basically run Windows, and that's made for a lot of good reasons, but generally speaking, it's because of the libraries. So Windows has Direct 3D libraries and DirectX libraries. These are the 3D libraries that allow you to actually run your games on a Windows machine. Now, if it wasn't for that, it's all about standardization. It'd be much harder to run, gaming apparel, especially your GPU and all this kind of stuff, onto an OS if it didn't have these libraries. And so that's exactly what's happening with the Linux guys. So people that run Linux or even Mac OS, they have a lot of issues because they need a programmer, a developer, to completely recompile, rewrite large portions of the game so that it can run fluently and well optimized on their machine. And that is really the big advantage with Windows, but it's a huge stride in our back, and I think it's going to change in a future, a very, very close future, because again, Windows is garbage. So Windows as an operating system, if you guys want to know a little bit about it, so all operating systems can be simplified with a von Neumann diagram. So von Neumann was a very smart guy. He basically invented computer architecture, and it basically how hardware works, how hardware communicates to itself. So this is kind of this is kind of a simplified graph of how it works. Later on, there are better graphs, but basically you have here you have your disk memory, which writes onto your storage, or sorry, your main memory, your RAM. The RAM is gonna have a set that is specifically for instructions. So in your main memory, you're gonna have your instructions, and then you're going to have your decode and execute as well. So your RAM, your memory serves as like a library that your CPU is able to grab books and read through them, and your CPU basically crunches the numbers that are inside the memory. So what you're really getting is your memory talking to your CPU. Okay, and von Neumann, who invented this whole architecture, he's a very smart guy. He knew what operations would be running through this system, and this allowed him to really have an advanced advanced computers very quickly on in the early beginnings of computers. So what does an OS do? Well, an OS kind of looks at the operations that it wants to maximize, and it's going to try to create an environment, a software environment with instructions, a program, a way of accessing the memory, a way of accessing the disk, etc., so that the CPU's power can be really maximized for whatever task. So this is where a lot of talks with like architecture and operating system architecture is going to happen. So this is very much the realm of computer engineers. Engineers, they basically try to make sure that this kind of stuff is optimized for whatever task. And there's a lot of different ways that you can optimize it. It's not like there's a one solution for everything. But there are definitely best practices. There's definitely a whole methodology to get really good results. I mean, look at this. This is a methodology in and of itself, just to get the hardware side of it understood. So you could just imagine how complex an operating system really is. And I want to reiterate that Windows is actually very garbage for this. So a little history about Windows. Windows is really based off of one thing, which is DOS. So DOS is a very, very old operating system that dates back to the Commodore and original Mac OS era. And what happens is that back then there was really just your executive and maybe a little bit of microkernel. That's about it. And what that means is when you have the hardware directly communicates to the kernel, and the kernel just basically tries to communicate with the services. So the services, the executive branch, is basically just getting the information either from I/O, security, IPC, virtual memory, power manager, or any of these services, main services, and it'll create objects and it'll execute the services, and it'll just use that using the microkernel, which is basically getting the hardware's information. So back in the day, DOS, which was actually very, very complex compared to like Commodore, let's say, it actually had quite a lot of executive. The executive was actually quite a large portion of the program, versus with DOS, you really had a microkernel, some memory management, but it was not virtual memory. IPC, did it really have an IPC manager? No, I wouldn't say, because for instance, IPC basically means that if your CPU was overclocked, then it would be able to kind of adjust the clock rate for the performance of the task. It did not have that. So for instance, even in early DOS, when you ran your Pentium, let's say at 133 megahertz, or like say you ran it at 166 megahertz, some games just couldn't handle that because there was no real IPC manager that was actually created by programmers inside the games to make sure that even if you ran an overclock, that it didn't do that. So this was not included. It had an I/O manager, of course. Did it have a security manager? No, that came later. I think that was, later. But you had a window manager and a GDI. So very, very simple compared to today. But what was the real kind of thing that you guys have to understand is that the executive, all of this was extremely static. So when we talk about I/O, for instance, we're not talking about how many USBs you got connected. No, no, no. We're talking about, okay, do we have your keyboard? Do we have your mouse? Do we have your monitor? Are all those things running at the same time? And making sure that in a clock cycle, these things are actually checked up. And so you had checksums and things like that for that stuff, but it was very static. You had to have a keyboard and a mouse and a monitor. If you had two monitors, the I/O had to have a portion of the code that actually made sure that this was the case. It's not like we cared about this kind of stuff yet, and so back then that was, a simple way of just doing it. The problem is that this is regular Windows. This is actually how Windows works, at least since Windows XP or NT. And when you look at this, what it really is a DOS, which is contained within a hardware abstraction layer, which is basically a virtual layer, which allows to modify the executive to better fit your needs, and to have your drivers and your microkernel talking to each other in a right way. Now, this even kernel mode drivers, this stuff was invented just in the late 90s, and yeah, okay, it was quite trivial back then. I mean, it was even, I would consider, like a new feature, but the problem is that they never changed it. How it works is basically it tries to get drivers for whatever device you might have. That's pretty much a regular example of what you might look at, and it tries to make sure that those drivers are up to date, to have that connectivity to actually work. It works with your I/O manager, your security maintenance, your IPC, to make sure that all that stuff works, and then it makes sure that the virtual memory manager actually has the memory to handle those checksums for the drivers. So you could just imagine how how much this might actually taken up in memory, considering that you have just about half of your memory, or sorry, half your virtual memory running for that. And in my opinion, Windows, because of all this kind of bloat, all this stuff that could have been simplified over time, that was not really thought through back in the day, and it was for good reason maybe, but because of all this bloat, it makes Windows one very underperforming, which means that you take any x86 CPU and you check out how it would run on Windows 10, and you just see how terrible it actually runs. And secondly, it was very unstable. So for instance, on my PC, I don't even have a very demanding computer. It's not like it has weird problems with it, but for some reason I have constant explorer.exe crashes. I have constant device manager issues where I have tons of bloatware drivers, stuff that's just not working for me. And the main reason is that again, Windows is very unreliable. It will not allow you to do the things you want to do. So how do you solve that? Well, the very first thing I say is to contain all this into a virtual machine. If you can do that from the get-go, either multi-boot or some sort of virtual machine setup, you're already way better than 99% of gamers, because you're not, if it crashes, it's not going to crash your whole PC. If it crashes, it's not going to ruin your BIOS, it's not going to ruin your overclock, whatever it may be. So that's a very important part, I would argue, for Windows. That's really the first part of this whole video. So I was just showing you guys kind of how it works, just so that you understand why Windows is such a big deal. And you can see it's just what it is really, at this point I would call it spaghetti code in there. It's just a bunch of spaghetti code, and that's terrible. So how do you fix that? The first thing is VM. The second thing is registry editor. So if you go here and you look up regedit, you'll get this regedit.msc, MSC, which is a Microsoft compute, I believe, or something like that. Kind of like a .exe, but specifically for Microsoft applications. Now, I don't want to go through all these files because some of it is private. You don't want to show off all your files to people. But what this is it's literally a way of modifying parts of the code of your of your computer. Now, what it actually is it's modifying the checksums, which is the part of when your memory goes into the instructions and back. So the checksum is right here, and basically what it's doing is it's making sure that you're getting the right information from the memory. So if you change your checksums, it's going to change the way that your disk sends information to your instructions. And so in some cases it can be pretty dangerous. If you poke the wrong thing here, you could break your computer. If you ever heard of like don't delete system 32, system 32 basically checks those checksums. So you don't want to do that because then your registry would be broken. So the thing with the registry editor is that there's a bunch of stuff happening around here that is total bloat. For instance, I'll give you a quick example. Why not? So if I bring up my task manager right now, you can see all the tasks that are running in the background. Here you got a bunch of stuff running in the background. Some of this stuff is really important. Other stuff is completely useless, such as start. I mean, this is a tiny app and it's running 30 megs of RAM. I mean, back in the day, that was a whole application and it's just running in the background and it's not doing anything. It's literally not doing anything. Search, even worse. Good thing this is not running. This is running like in the cache. It's not actually running. This stuff. Postgres is running for some reason. NordVPN is running. Afterburner is running. iPod service. This is all bloat. This is all stuff that shouldn't be running, and yet it is running. And some of it is my fault. Some of it is just drivers, like all this AMD stuff. Acrobat. This is useless, right? Absolutely useless. And then there's a whole bunch of service hosts. So the registry editor, you could change this and it could give you better results in terms of FPS because you're running less things in the memory right around here. Less things in the memory, which means less things that the CPU has to handle, which means a more stable and a faster gaming experience. So that's really the first thing I would argue. Now, if you go online, and you look up Windows 10 gaming edition or something like that, Windows 10 hacking edition, overclocking edition, these are going to be scripts that are going to go through procedurally your registry editor and delete whatever is completely useless. My old computer, I had done it and I gained an extra 5 FPS in Warzone, but I would argue that my latency was quite better, probably around 3 to 7 milliseconds better. And this is just from my rough look at it, but I played Warzone so much back then that I think I'm willing to say that it was actually quite significant. So that's the first thing I want to talk about today. Now let's head to the second topic. It's already been quite a long video, but hopefully we'll be able to finish this pretty fast. The second topic is fast clock, stable clock. So if we go back into the architecture here and we see this IPC manager, IPC manager means that for each instruction that is asked out of the CPU, the clock rate is going to stabilize for it. So what that means is that whatever clock rate you run, it'll stabilize and optimize the windows instead of just running Windows faster. So back in the day, like I said, if you ran 166 megahertz for a game, it might not work. You'd have to downclock. Sometimes you had to overclock for games to work, things like that. It's no longer the case. Now you can run your clock rate dynamically and it won't mess up with your windows. So that's pretty cool. And that's a huge advantage that you should definitely check out. So for instance, if you buy, let's talk about a brand new CPU. If you buy a 12100F or now the 13100F, which is getting cheap, this is an i3. It's a quad core. It's very good for $100. Very good CPU, but it only overclocks to like 4.3 gigahertz. All right. So what does that mean? Well, does it mean that it can't go higher than that? No. What it means is that Intel decided to basically give you guys a certain amount of performance, but they didn't want to kill their i5 segment. So they sort of arbitrarily chose 4.3 gigahertz, whether it's for TDP reasons, whether it's for cheaping out on some specific things on the die, whether it's for low bins, it doesn't really matter. But what does matter is that your actual clock rate is actually downclocked from what it could be. So a lot of people have hit 5 gigahertz with their i3s. Some people have even hit 5.3 gigahertz with their i3s. Now that's almost a whole gigahertz that you're completely missing out on. And 1 gigahertz, I mean, we're talking like 30 to 60, 30 to 40% more performance out of the gate. Gaming, we're talking easily at least 20%, right? So that is actually quite a lot of difference. And with a fast clock, not only are you getting a lot more performance out the gate, which basically means that when Windows is trying to access your computing power, it's able to do it much faster because again it has just more raw performance to actually do it. But the second thing that people don't realize is stability. So in Windows, we're actually really lucky now, because if we look here, this virtual memory manager. So how the virtual memory manager works is it spits out a certain amount of memory that the computer is allowed to use. So right now, if I look at my task manager and we see that I'm using 13%, if we looked at just the Windows application, so for instance, Windows Explorer is using 75 megs, if I gave less actual RAM to my computer, so right now I have 64 gigs, it's quite a lot of RAM, but if I was actually running less RAM, what would be really cool is that my computer would not use it all. So right now, the virtual manager only allowed 85 gigabytes of RAM that was also compressed. Okay, so this is really cool. Here you have your committed and your cached, your paged pool and your non-paged pool. This kind of stuff is all dealt with by the virtual manager. So in the virtual memory manager, it makes sure that you have your RAM to be dynamically allocated, making sure that it's optimized, making sure that whatever it's not in use is compressed, etc., etc. And what happens is that it also checks for errors. So what happens with Windows back in the days, you'd get a lot of blue screens. And what would happen is that you'd have an error where, like, for instance, say an operation wasn't detected properly, or say that, for instance, when the memory tried to push out some instructions to the CPU, it failed. Or the opposite could also happen. The CPU pushed out some random numbers that don't make any sense, and it also failed. With the virtual memory manager, what it allows to do is it allows it to find those errors and to kind of try to fix it. Now, there's a whole course on how it does it. I'm not really going to get into detail. Let's just imagine it was just magic, right? The problem still lies that when it is trying to get to detect those problems, whether it's memory, whether it's a faulty clock, it could be really anything. But when it does try to detect it, it is going to use up some of that performance that very second. That's why if you look at like unstable computers, if you look at like unstable drivers, whatever it may be, you will have really bad latency, and sometimes that's actually because in the background Windows is like trying to catch up with the actual applications dealing with a bunch of errors. If you ever deal with like gaming crashes where you're playing a game and just randomly you get this white screen, that usually happens because something in the game sent out or spat out a faulty or error prone memory, and Windows just didn't know what to do with it, so it just decided to kill the application. That's all the virtual memory doing that. So more clock rate means also more stability, because when you do fail, it'll be faster to just fix that. Just something to keep in mind. That's the first thing. The second thing is also I/O. So I/O, we're gonna get into that a little bit, but I/O again is if you look at if you look here at the how the system works, the I/O is a manager, and it connects. It's detecting and connecting all things that are connected within your computer. So right now I have a microphone, I have a keyboard, a mouse, I have 2 monitors, camera, I have a bunch of random iPods that are charging on my computer. I have just tons of stuff connected, and that's all dealt with the I/O manager. The thing with the I/O manager is that there's multiple types of I/O, and some of them have a higher there's a hierarchy of I/O. So within the I/O, there's some things that will be dealt with first, and then the other things will be dealt with later. So for instance, USB is going to be dealt with a lot later than say PS2. So PS2 is probably one of the best to run with I/O, and that's what I'm running with my keyboard right now. And that's because PS2 has a keyboard interrupt setup instead of it just being a driver that just basically runs in the background. So the difference really is that if you look here, you got a disk memory. Your disk memory sends in instructions, which then sends it to the CPU. So what happens with the CPU, whenever it's trying to get USB information, it's going to ask for a fetch. Okay, so it's going to say, hey, listen, I'm going to listen for the USB and see what's going on. All right, so that can happen like once every 50 cycles. So that's quite fast, I mean, overall. But the advantage with PS2 is that PS2 is up here. It's an interrupt. In an interrupt, I mean, there's not many like applications for it. So nowadays, not many peripherals use it. But PS2 is one of the rare ones that do. And what that means is this: it's a service interrupt. So while the processor might be trying to fetch something from the USB, the PS2 could go up one and completely cut off the machine cycle and ask for something to happen. So because of that, PS2 is much faster to be detected than for regular USB. Now, the way that Windows kind of tried to fix that was with USB HID, not HIV, HID. And HID, this is IDE, not the same. HID right here. So HID is a type of USB interface, and what it is basically a dynamic listener. So that's like the design pattern code for it. What it means is that the processor is going to fetch it once, and then it's just going to run in the background, just like a instruction program. So that way, you got a virtual registry that takes up all the input of your USB. Okay, so USB HID is relatively new for kind of, you know, what the purpose is, but what it is a band-aid to try to fix USB, and it fixes it in three ways. The first way is that it's relatively low latency now, instead of USB, which was the fetch once per 50 cycles. That's actually kind of slow compared to running it HID. HID will just constantly take the string of inputs that you might send, and the CPU has no choice of running it in the background. So when you're running a multi-threaded CPU, it's actually quite fast. But the problem is that again, you still have all the disadvantages of USB. So one is that USB is driver oriented, which means that you have to have drivers to run it. And drivers are inherently programs, which means that they're inherently going to use up some memory. So you could have stability issues, whatever. Obviously, clock rate fixes that a little bit, but again, that's one of the issues. The next issue is N key rollover. So N key rollover means how many keys are you allowed to press for a single input. Now, originally USB was limited to 4 bytes of information, and what that means is that you could only have 4 inputs. Then they simplified it to 6, but that did not include Shift, Control, Alt, Windows, Enter. All those keys were still worth one whole. So that would actually made a lot of issues. So 6 was the limit. Then what they ended up doing was with HID, you basically had unlimited limitations so long as the virtual memory allows it. So again, you were limited by the VMM, which is a problem in and of itself. But the very last thing where did I put this? Okay, the very last thing that they fixed with it was N key rollover. Now there's a couple ways they fixed it. One way is just through the registry. Another way is that they ran USB through the BIOS. So there are some USB manufacturers that still do this. They'll give you 2 USBs for a single keyboard. They don't do this with mice, sadly, because nowadays mice doesn't really matter. But with 2 USBs, one of them is going to run into BIOS bypass system, and the other one is going to run into Windows main. And what that means is that you can now run it through a much lower level of the USB drivers, and so you don't have to worry about it as much. So what's really important for a keyboard nowadays is polling rate and USB type. So making sure that your drivers and your polling rate are very fast will pretty much destroy everything that I just said. I am still using a PS2 keyboard, me personally, because again, you get that N key rollover. I can basically click every single key on my keyboard and it's not going to do anything. So for someone like me that writes at over 80 types per minute, it's actually very useful to have that, because again, when I'm typing really fast, I want all that to be inputted onto the keys. Right now I'm writing, and I'm actually writing a novel. It's kind of like a teen sci-fi novel, and latency is still very much of a problem in the future. And again, getting that N key rollover, I feel as though really benefited my writing skills, because otherwise I would have had a lot of issues just writing. It like breaks my focus. It's like every couple of seconds something is stopping me from writing. And I've noticed, like, just writing generally with this keyboard over my last one, which was kind of like I think it was a K55 or whatever. This Rosewool keyboard has just been way better for my typing skills, and also just writing off of intuition, just writing what is going on in my head. It's very fast. So that's pretty much it for fast clock, stable clock. Now is for timings and perceived timings. So memory, let's go back to memory. Memory does what? It spits out instructions to the CPU, and the CPU resends information. So what's really important for memory is to do this, to have enough memory for all this to happen, but also to do it as fast as possible. And there's 3 ways of calculating memory speed, but it's all in the CAS latency standard, and also the render bandwidth tests. So with most memory nowadays, we care more about CAS latency. Back in the day, bandwidth, your render bandwidth test was much more important, but now CAS latency is becoming more of a question, because now that the chips are so big, you could get in a single RAM chip, you can get like 8 gigabytes of RAM. What that means is that the actual bandwidth is very fast, but it takes quite a while for it to be filled up. So now CAS latency is more of an issue. If you want to run Windows very stable, you basically make sure that all your CAS latency is pretty much all the same. When it's all the same for the VMM, what happens is the VMM really likes it. It has a tendency of liking like stable latencies. Some of the latencies, it's a little bit more lenient. So for instance, the first and the third latency can be a little lower than the second, and it actually generally likes that. If the second is lower than the first and the third, it doesn't like that at all. So when you're looking at RAM, so for instance, I'm looking at DDR5 7200 RPM, megahertz, and then the CAS is 36, 40, 38, and then the rest is quite important usually, but in this case it's not. So CAS latency has been more and more of a topic, because again, it's just going higher. If you're looking at like DDR4, for instance, DDR4, if you're looking at like 4400 megahertz, it's only going to be 17, 19, 17, I believe. That's very low. That is amazing bins. And honestly, I would rather go DDR4. But again, with DDR5, because you get such a bandwidth advantage, which is really advantageous for people like me that like to use up the memory and do stuff with the memory, have some memory shenanigans, let's say. You can't go away from, I can run this 8000 megahertz no problem. So you got to kind of make sure that this memory is going well. Notice that the first and the third are kind of similar, and then the second is bigger than the next two, and that's just how the VMM likes it. That's really the way I could explain it. The best way I could explain it. So that's memory. Perceived timings is what happens when the computer, the VMM, has a preference on timings because again it doesn't optimize for certain timings, and other timings it does optimize. So a good example of this is like if you look at like TCRL or the other one, what it's really checking in terms of cast latency is it's checking for a type of memory operation that is very rare. So because of that, the perceived timing of this one might be very long. It could be like 40, it could be like even 44. But because of that specific timing, is not really used all that much, it doesn't matter so much. And actually for the chip, for the actual memory of the chip, it might not be worth it for you to tune that specific memory to be very low. Because again, you might be able to have more leeway with other memory timings, whatever it may be. And that's why the perceived timing is very important. Okay, and now finally, we're going to go into the closing words, kind of talk about keyboard, mouse, monitor, sound, and loading topics. So we're going to start with keyboard and mouse. So anything that is vision, so your eye is here and you're looking at like a monitor, you got a keyboard and a mouse, this is going to be limited from physical factors. Even the sound, if you think about it, the sound is also limiting. And the reason is pretty simple. It's that, our eye, our hands, our actions are already limited to a certain milliseconds. Some people say it's like 100 millisecond. I really doubt that it's 100. That would make basketball games kind of slow, but it is limited. And because it is limited, we can calculate it using like Newtonian structures. So okay, well, if this is 15 milliseconds, then it's just this is like 20 milliseconds plus 20 milliseconds plus they say it's 8 milliseconds. So there you have it, right? And then you could just add that all up. So that makes it really easy. And what that also means is that it's very easy to determine how much percentage of drop of latency you actually had. So if, say, like you started with a 40 millisecond monitor, now that's just an example, I know they don't make those anymore, but you start with a 40 millisecond monitor, you get it down to 1 millisecond, because you could just calculate it real quick with just adding it all up. It's actually really easy to determine how much of a benefit it's going to be. And so when you do play the game, you'll actually get better scores, and it's going to be pretty much like scientific, like 1-to-1 with what happened in terms of latency. So that's something to be pretty courteous about when you're buying your peripherals. It's just making sure that you're getting really good latency. Now, what would I suggest for most gamers is to get comfortable with a mechanical keyboard, get comfortable with any mouse that is wired, and that is like relatively gaming oriented. So you want to have like 500 hertz polling rate. Keyboard, also 500 hertz polling rate is kind of nice, although 125 hertz is just fine most of the time nowadays. And then for your monitor, just get yourself honestly start with the 75 hertz. Why the 75 hertz? Because when you're going to go for a higher monitor, you're not going to be crutching on the monitor. So for instance, when I go to my friend's house and he has like a 60 hertz monitor, I'm not going to blame it on the monitor. I'm actually going to be bad. Versus if you start with 75 hertz, you get comfortable with that, you play video games on that, and then you head over to your 144 hertz, 165 hertz, whatever it may be. It's much more comfortable, and you actually realize how much performance you got out of it. So do get better on a lower end monitor and then make your way up. In terms of keyboard, mouse, monitor, so for keyboard, the easy trick is to buy a PS2 monitor, a PS2 keyboard. Any keyboard that has N key rollover as a standard spec is technically a PS2 keyboard. You could just use one of those quick converters, like female to male USB to PS2, and that should work. Now, obviously, the limitation there is that you need to have a motherboard that has PS2. We sadly don't live in a world where there's like such a thing as like a PS2 card. If you ever buy a PS2 card, that's running through a driver, so it's actually going to be slower than USB. But PS2 is really your standard. The second best thing I suggest is something that is higher than a 12 NK rollover. It's 12K rollover if you think about it, but 12 NK rollover. For instance, like I'm getting a 20K K rollover. Some people, they want just like a very high K rollover. The whole reason why 12 is fine is because at 12, there's just too many keys that it's not really gonna matter unless you're playing like Osu or, Dance Dance Revolution on your keyboard. That otherwise it's not gonna matter. So don't worry about that. The last thing that I would suggest, like you're really your last bet of keyboards, is to just make sure that it's a mechanical keyboard. So long as you get a mechanical keyboard, you should be pretty comfortable with it. Your advantage is still within 20 milliseconds, so that's not really that bad. It's like the difference between running a regular monitor and running a 200 megahertz monitor. So it's not really like a huge difference overall, but again, making sure that it's at least a mechanical keyboard, because you want to get used to that key press. Some people are not used to it. They use very low amount of pressure on your key, and that can be pretty annoying. With your mechanical keyboards, especially like Cherry MX Red, Brown, and the other one is like your Speeds or whatever, all your new ones that are just kind of like between a red and, oh yeah, the greens, like between a red and a green. I know green is Razer, I don't care. Again, that will help you just getting that mind connection, that muscle memory of tapping on it, and that's totally fine. One up better is NKRO, one up better is PS2. PS2 is really the best. It is getting a little worse than before, but the advantage because again, if you're running 1,000 hertz NKRO, because of USB HID, it's gonna feel basically the same, even a little better in some cases. Your average speed is also going to be a little better than your PS2, but the thing with the NKRO is that it'll depend on how many keys you actually press, versus PS2 is usually not going to depend. It's just going to depend on how many packets it's able to send. It's a different topic. But the cool thing about PS2 is that you can actually overclock them at 200 hertz. So that's what I have mine right now, and it's a very beastly. So that's keyboards. Mice is a lot the same. You don't get to choose what input you want from a mouse, and so it's a lot more feeling. Make sure it feels good in your hand. Make sure it's start with a cord. What do you call that? A wired. If you can make sure that the feeling is good and it's a wired, you make sure that it is a wired, you'll be fine. What did I start? Like, what was my first mouse? It was a WMO. That's a $10 mouse. So it really doesn't matter that much. We live in a time, my dad was telling me, like, we live in a time where, you got optical mice. He lived in a time where it was freaking ball, and he had to clean it every time he wanted to play Quake. So it's just completely different. And mice is really, like, again, just look at your budget, think about what you want, and make sure it's wired and it's got a good feeling, and you should be fine. Monitors. So monitors is a whole question, because again, you have three things going on. You have feeling, you have refresh rate, and you have input. So input is the easy one. If you're running anything under 1440p, HDMI is fine. If you're running anything over that, then DisplayPort is the only way. And don't really get too saucy with whichever one you choose. HDMI is going to be cheaper overall, but DisplayPort is going to allow you to run multi-monitors easier. That's the key point. Make sure that your graphics card kind of does it, and you'll be fine with DisplayPort. So HDMI is totally fine. Make sure it's a 4K, those new cables. You don't want to start messing around with multiple types of cables. If you're running a low refresh rate HDMI cable, just run that. If you're running a high refresh rate cable, make sure that you bought, like, it's explicit. Like, even me, I have a, I tape code my my HDMI cables because sometimes I forget. Your best bet is just to keep the HDMI cable with your monitor, and you'll never forget. That's the first thing. Second thing, refresh rate. So again, like, I have friends that are a lot more like advanced with refresh rate. They care a lot more about this kind of stuff. I would argue that so long as your refresh rate, which is usually static, so long as you have a high refresh rate, let's say like 165 hertz, and you have zero ghosting, you're gonna be golden. Now, what's ghosting? Ghosting, that sounds weird, right? What is that? Well, it's very simple. What happens is that when you run a ton of pixels all at the same time, the lighting of each pixel is going to interfere with each other. And what happens is when you're running a really high refresh rate, those lights, those LEDs, those really tiny LEDs you got on your monitor, they don't have time to close fully. All right? Especially at high refresh rates. So what happens is you're going to get what's called a ghosting effect. It looks like a shadow of the last frame on your computer. And it is so prevalent. Like, I see it all the time. I see a lot of friends, they have like Fortnite, whatever. They're running games and they think they're running at high refresh rate, but then I'm literally looking at the previous frame. I literally see the enemy that killed me, 1 frame ago. And it's very distracting because, again, it's literally like you're looking at a shadow. So what I suggest is to start with either a very good Chinese 100 megahertz plus monitor, or to just start with a 75 hertz and then overclock it. Either way, you're going to get right around between 90 and 120 hertz, or sometimes 144 hertz, and you'll be able to kind of get used to like monitors today. Some people, they get more technical. I know some people, absolutely autistic, they'll buy a CRT monitor, which is a 4x3, and then they'll just drop the resolution to like 800 by 600, and that allows you to run like 85 hertz. Some people, they say even like 120 hertz on a tiny $20 CRT monitor. That's pretty smart. I mean, why wouldn't you do that? Well, the main reason why you wouldn't is because CRT would hurt your eyes, but I digress. One technique I've figured out is you buy an old 3D monitor. So right now the one I'm looking at is a PlayStation 3D monitor. It's a 24-inch. It's the same size as my girlfriend's. My girlfriend has a 144 hertz that she bought a while back. And then you overclock it to the 240 hertz. And because the LEDs allow you to kind of, well, they're kind of, the monitor was binned to support 240 hertz. Once you overclock it, it's not going to feel any different. So that's one way you could do it. It's just buying an old monitor that kind of can do this, and then you just kind of overclock it. And that's what I used to do. I used to have an LG ultra wide, and I was running it at 85 hertz when it was a 75 hertz monitor. That's pretty cool. Let's talk about loading now. So loading is a whole topic. It's less relevant than before, but it still has some prevalence in some games. Loading, where does loading really affect latency? Well, right now for multiplayer games, it doesn't really affect it all that much. The most I could say is like in CS:GO, it used to be the case that when you would get sprays on the wall, it would kill some of the FPS. So with loading, there's two ways of doing it. The first way is RAM, and the second way is disk optimization. So disk optimization, some games allow you to explicitly tell them how much you're going to save on your disk. And if your disk is very fast, such as Optane, such as Gen 5 PCIe, whatever it may be, allows you to basically have some, a secondary pair of memory for your video game. But you have to do it explicitly. That's kind of annoying. With RAM, if you get a lot of RAM and you have very low latency for your RAM, so for instance, I'm running 64 gigs of RAM, but it's low latency, but it's not very fast bandwidth. it is a little problem. But if you do have, you know, let's say like DDR5, 8000 megahertz, CL, let's say like CL28, right? You're just gonna have a much better time at running it, and your application will be able to run in VMM, and VMM is never going to complain, which means you're going to have much better time loading up. I think the disk is smarter if you're running a single player game, because in single player games it's procedurally loaded it's explicitly loaded, and then when you're running like multiplayer games where they just need a little bit of RAM in the background, such as Warzone, CS2, games like that, Civ, those games you do need that RAM, so I suggest having more RAM than usual. So if you run like 32 gigs of RAM, overclock it, run it very low latency, you can have a better time playing video games. Now finally, let's talk about sound. Sound is not a topic I want to I'll just basically finish up with sound, because it's not super complicated. Right now, if you're running sound, it's either coming from your motherboard or your GPU. Some GPUs, they virtualize like a sound engine, and that's pretty cool, but it does use a little bit of performance. It's like what you call driver overhead. You don't want to have that. You want to have as little driver overhead as possible. That's why, for instance, I don't have the Radeon Experience driver thing anymore, and honestly, it never crashes anymore. My GPU never crashes anymore, so I'm really happy with that. So you could run off the motherboard. The motherboard is not a bad idea, but the problem is that it's always been a challenge between sound clarity and actual impedance. Being able to run very good headphones means usually you need to run over 100 ohms of impedance, whereas running like speakers or running like cheap headphones, it might just be like 7 ohms, sometimes like 30 ohms. It's basically nothing compared to really high-end headphones. Me personally, I got some DT770s. They're decent. They're not super high. I believe, they're 80 ohms. They're not super high. But again, when running it off the motherboard, I could tell right away. It just sounded like garbage, like absolute garbage. So what I did was I wanted a standard sound, and I wanted it off of a specific driver that is a low overhead, and that could just run on the background. I don't have to do anything. So what I did was I bought a sound card. It's a PCIe sound card. PCI sound cards would be a little better because they have basically like no overhead at all. But again, what motherboard has PCI these days? So PCIe X1 is best. The ones I suggest are you could buy used. You could buy brand new, like an AE5, or what would be the other one? A Xonar. Some of the Xonars are pretty decent. And then the other aspect you could do is you could try to shop for a motherboard that does have a very good sound card. Not many anymore, but some of them still, boast about it. So that could be worth checking out. Lastly, you could also buy an external. So here I have an external. I'm holding an external DAC right now. This one will run off of USB. It's not going to be as good as PCI and PCIe, but again, running this will at least give you some standard of sound. And sometimes they have very good 3D sound engines, so that is something you could definitely do. And the ones I would suggest is the titanium external. I find that one quite good, and it's you can actually modify the internals. Some people, they very much like the what is that one called? The Solo. That's the one that I'm thinking of. The red Solo. That one's okay. I don't have any problem with it. It's just more. It's not so much for gaming. It's more for like sound mixing, which is fine. So sound is like its own thing. It's got a bunch of stuff, but really just getting a standard crisp sound is what's really important. Getting something with some bass, getting something that you're sure that the drivers will have dynamic sound, like 3D sound, things like that. That could be pretty important in some games. Other games like CS2, it just doesn't matter. So just make sure that every peripheral that you have here is optimized for the games that you want. And at the end of the day, what this all really matters for is longevity of playing If you want to play games 5 hours plus through the day, and you want zero crashes, you want high FPS right at the end of your game, making sure that all this stuff is running properly is going to definitely advantage you. I forgot to mention one last thing. Windows is garbage, and one way that it's garbage is that it has to check for the applications you have installed. If you have a lot of applications installed, it will actually run your gaming performance slower, because it is constantly checking for other applications that are running and applications that are potentially going to run. So making sure that that's checked, you could do it in two ways. The first way is you don't install all those applications. The second way is you basically you make sure that within the Windows parameters, I don't remember the name of it, you basically disable them, like you explicitly disable them. That usually works, but again, like you could look at my bloat, for instance. I mean, it's absolutely insane. Most of this stuff I don't need, and it just runs in the background. I don't even have a choice, like stuff like, iPod service. So yeah, that's pretty much it for today, guys. I mean, it's a whole ass video, but again, we talked about so much. We talked OS, we talked peripherals, etc., etc. It's a very, very complex topic, and it's something I've been, thinking about recently. I will be having a project coming up, a wireless mouse that I'm going to build into a G Pro X super light mouse. That should be pretty fun. I'm gonna have some footage there. And next up after that will probably be my iPod, my SSD iPod project. And I will probably make some more videos during 2024. I will be uploading a couple more kind of found footage types videos, a la Greenham Gaming, a la, like whatever you might call it. And in 2024, I will be more retroactive on the channel, just because I have more time now, and generally speaking, the video game hobby has not escaped me entirely, but I will be probably getting into my other hobbies a little bit more now that I have the budget to do so. So I hope you guys enjoyed, and have a great day.